Okay, now we're going to move on and we're going to apply all that knowledge that we've learned about ionic equations and half equations to a particular type of chemical equation, which is called electrolysis. All right, now before we do that, we just need to do a little bit of recap on electricity. So this is an electric circuit. Here I've got a battery and I've got a bulb. All right, and this is the positive end of the battery and this is the negative end of the battery. And what happens is that inside the wire here there are electrons. There are electrons all inside the wire. And when the circuit's connected, current will flow around, and that is the flow of electrons. So there will be electrons flowing around the circuit like so. Okay, and the electrons flow from the negative terminal to the positive terminal. And because of that, the bulb comes on. Okay, so the electricity is flowing, so the bulb comes on. Now, let's imagine I've got a different circuit over here. I haven't quite finished drawing this circuit out. So it looks like this one so far. And I'm going to come down here and I'm going to end it like that. Okay. Now, in this circuit, because it's not connected, the current can't flow. So the bulb won't come on. All right, and it's just because we've got this break in the circuit and the electrons are not able to flow all the way around. Okay, and what I can do is I can just bring this down here and I can just have these two ends here that are just in open air. Okay, and because they're like that, the electricity can't flow between them and the bulb won't come on. All right, now what we're going to try and do is we're going to try and put something in between these two ends of the circuit to see if electricity can flow across. So at the moment there's just thin air between them, so the current can't flow along, all right, because there's no charged particles to carry the electrical current between those two ends of the circuit. Okay, so it's worth noting that for current to flow, there must be charged particles remember, not just charged particles, but they also must be free to move. Okay, so what I've got down here are two different situations which potentially are going to allow us to finish our circuit. All right, so let's do this first one. So if I draw my circuit around this, it's going to look like this. I've still got my bulb here, and then I've got the end of the circuit like that. And I can bring the other end around here and attach it to the other side of my solid. Okay, so you should be able to tell that this here is an ionic solid. Because it's got a regular shape and it's got alternating ions, so it is an ionic solid. Now, we turn the battery on. Okay, the electrons are going to want to flow around the circuit. However, when they get to here, they're not able to go across here. And also, even though we've got charged particles in between these two ends of the circuit, none of these charged particles, none of these ions are able to move. So they're not able to carry the charge for us. Okay, so this bulb here will not come on. Okay, so again, current does not flow. Now, of course, you can try this yourself anytime you want. You can get yourself a battery, your beginner electrical circuit kit, connect some wires to a bulb, and then just get some salt out of the cupboard and see if you stick two ends of the wires into the salt, see if the bulb will come on. And it won't, because these charged particles cannot move, so they cannot carry the current. All right. Now, what I've got over here is something slightly different. So what I've done is I've taken this ionic solid and I've heated it up. Okay, and I've heated it so that it melts. All right, so this is now a liquid. Okay, so this is now a molten ionic compound. Now, in order to do that, you'd have to heat something like salt in your cupboard, so sodium chloride, which looks like this, the stuff you put on your chips. If you want to heat it up, you're going to need to heat it up, if I remember correctly, to at least 1,000 degrees C. All right, so it's really hot. All right, but now, if I connect it to my circuit, if this was possible, all right, now the electrons flow around here, and when they get to here, these charged particles, because they're in the liquid state, they're all free to move. Okay, so these here, these are all charged particles which are free to move, which is, you'll remember, our requirement for the flow of electricity. All right, so what happens is, when the electrons come round, okay, these charged particles are able to carry the current. Okay, and we're going to go now look a little bit more exactly how that happens. Okay, so just let's not forget that that's going to come on. So let's now think about this in a little bit more detail with an example. So I've drawn out another setup here. All right, we need to remember that this is the positive end and this is the negative end. Now, I'm not going to draw out all the ions again, or else it will get a bit complicated. Okay, but let's suppose that this is molten NaCl. Okay, so NaCl liquid. So, in my molten sodium chloride, I'm going to have two different types of ion. I'm going to have my Na plus ions and my Cl minus ions. Now those are the only two types of thing in there. Okay, now I've drawn this up here to show you that it's full of liquid, but I don't want you to think that there's any water in here or anything like that. I've only got molten sodium chloride. There's no other thing in there. Now, what happens is the electrons come down here through the circuit. And so at this end, I'm going to have electrons, which means that this end here is going to be negative, and this end here is going to be positive. So what happens now is, because this is negative, it attracts towards it the sodium ion. And because this is positive, remember, because the electrons are moving around this way, so electrons are moving away from this end, it's positive, which means that it attracts the chloride towards it. Okay? Now, we're going to call these two things here, these are called electrodes. Okay? Now, at the negative electrode, what do I have happening? Well, I've got my Na plus is going over here, and there's loads of electrons at this end of the electrode on this electrode. So my Na plus is going to gain an electron. And if that happens, I make sodium. Okay? Now at the positive electrode, I have my negative chloride ion is going over here. So I have Cl minus, all right? And that's going to come over here, and it's going to give away its electron, because you imagine this is a negative chloride ion, and this positive electrode, it's positive because all the electrons are moving away through the circuit. So the electrode is going to take the negative electron off chlorine, okay? And when that happens, we're going to add, so the negative electron is removed from chlorine. However, we know that we can't just have chlorine by itself. We have to have Cl2, okay? Which means that I must have 2 chloride ions, okay? And they are losing their electrons. Okay, so the chloride ion comes over here and it loses its electron, and the electron goes into the circuit. Right, so what's happening is that we need electrons to get from here to here, and they do that because the sodium ion will take the electrons away, and then the chloride ion will give its electrons so they can carry on up there. And therefore, current will flow through the circuit because these two reactions are happening.